Alright, hey everybody. This week you guys are going to be going over things like comparing different functions and writing equations from a graph or a table, and even looking at distance versus time graphs and telling me, things like linear versus nonlinear, increasing versus decreasing. So this video is to help you guys to sort of remember a little bit about each of those. So as I'm going through some questions, I'm going to stop at some points to ask you a question. We're going to try out Edpuzzle and see how it works for math, so I'll need you guys to tell me your feedback later on. But I'm going to be stopping at some points to see you guys trying out these problems as well to see how much you remember. So here's the beginning, just sort of going back to how do you find slope from different types of things. So letter A here. This one is an equation already, so you know it's y equals mx. M is your slope. So if I was asking you what is the rate of change or what is the slope from here, you would just say, well, it's 29/5. So this you really don't have to do too much. You kind of just have to look and see what the answer would be. So letter B is a little bit more tricky. Remember when you have ordered pairs, you have all x's and y's. When you have a list of ordered pairs, though, you can choose any two that you want to find the slope between. So if I were looking at these, I would pick the ones where there's no decimals because it's a lot easier to figure out. So remember, you find the change in the y's or subtract the y's. So I'll do 17 minus 12 over the matching x's. Make sure you subtract in the same direction you did before. So 4 minus 2. So this gives me 17 minus 12, which is 5, over 4 minus 2. And that's it. So that would be what I would say is my rate of change or my slope. Let's take a look at a graph just to remind you of what it is. Remember, we do rise over run. So I already have two dots on here, so I would just connect them. If you look at the scale, it's kind of funny. So it looks like we go up 21 and over 4. And that's it. Now, if you absolutely want to change these to decimals, you definitely can, but this tells me my rise over my run, so I like to keep it like this, but you can change it to a decimal if you would like to. All right, let's move on to letter E. Now, if you forgot these are a little tricky. They're not in the form y equals mx plus b, so I have a video posted for you that's more in detail about how to change these, but I'll briefly remind you of how to do it on this video. So remember, you add or subtract your x term to get rid of it. So I have a minus 12x. I want to move it or make it 0. So I add 12x to both sides. So now I've got 2y equals 36 plus 12x. Now you divide everybody by the number in front of the y to make y by itself. So now, I'm running out of room. I've got y equals 36 divided by 2, which is 18, plus 12 divided by 2 is 6. Make sure you keep your x. The number in front of the x is your slope. It's written in a different way, but the number in front of your x is your slope, as long as it's in the form y equals mx plus b. Okay, last one together here. Go down to letter G. The table is just written kind of sideways, but it's the same thing as the ordered pairs. You can literally pick any two that you want on here to subtract. So I'm going to go with the negative 3 and the 2.5. So I've got negative 3 minus 2.5 over the matching x's, so 0 minus 2. This gives me negative 5.5 over negative 2. And if I type this in my calculator, it gives me 2.75, which is the same thing as 2.75 over 1. So what I want you guys to try is, if you look at letter F here, here is another table very similar to the one I just did. I want you to find the slope of letter F. And then I want you to find the slope of these ordered pairs. So back to letter B, what we did above, I want to see if you can do that, okay? Now on to the next part. This is writing equations in the form y equals mx plus b in many different ways. So sometimes you're given the slope and the y-intercept, so you actually just have to write it out. So we know m is your slope, b is your y-intercept. So if you're to write it in this form, you just replace the m with your slope and replace the b with your y-intercept. Now you don't need that 0 there, so you can actually just have y equals 5 halves x. Okay? Down here, this one's a little more tricky because of the minus, so I want to make sure to show you that. It's still an m and still a b. But we've got y equals, this is my m, mx plus b. Well, it'd be plus a negative 2. If you forgot, plus a negative is the same thing as minus 2. Now you don't need that 1 there, so you can really just write negative x minus 2. Alright, on your own, I want you to just try number 3. Put it in the form y equals mx plus b. And you guys will be able to see if your answer is correct using our Edpuzzle. Alright, let's move down to a table. Tables are very similar, again, to ordered pairs on how do you find the slope at least. So let's first, we know we're going to be using y equals mx plus b. So we need to subtract our y's over subtract our x's. So I'm going to do 4.5 minus 3.5 over 1 minus 0. Which gives me 1 over 1, so that's pretty easy. Our slope is 1. And now if you forgot how to find the y-intercept from a table, remember where x is 0, that is your y-intercept. So my y-intercept here is 3.5. So my equation would be y equals 1x, or just x, plus 3.5. Okay. See if you can figure out the y equals mx plus b for this table right here. Alright, let's move on to the next kind. From a graph here. If you forgot, again, how to find the equation of a line from a graph, first find the slope, meaning pick 2 dots on the graph. I'm going to pick these 2. Make your slope triangle, count your blocks up and then over. So I go up 1, 2, 3, over 1, 2, 3, 4. So I know my slope is 3/4. That's the number that goes in front of your x. It's a positive line, it's not going downhill, so I know it's positive 3/4. And it crosses the y-axis at 4. So plus 4. And that's all we do for those kind. So I want you to try to see if you can figure out this one right here. Figure out where the dots would be. And then where it crosses the y-axis, and see if you can do y equals mx plus b for it. Alright, we're almost there through the review. Here is the comparing part. So sometimes you're given more than one situation or a couple different options within a situation, and it's asking you which one has the greatest rate of change, which one has the smallest rate of change, things like that. So this is going to be in your quizzes that you have. See if you guys can remember what we do here. So for letter A, it tells me that a tree was 5 inches tall when it was when it was first planted. So we know that is my starting point, or my y-intercept. It grows 4 inches every month. So we know it's going to be y equals 4 inches every month, and it started at 5. So my equation for my tree, for this particular tree anyways, would be 4x plus 5. So very similar to what we did in the examples before. You can have a table where we have our x's and our y's. I always come up with the equation first because it's so much easier to tell the answers to these questions. So pick 2 of your y's, subtract them over your matching x's. So 12 minus 3 over 2 minus 0, which does come out to be 4.5, or you can just leave it as 9/2. So y equals 4.5x plus, where x is 0, that is the y-intercept. Okay. For the tree in the graph, we know, I'm just going to pick, let's do 38, I think, up here. And then down to 10. So we've got 38. We go up 28 over 8. So what is 28 divided by 8? That should be about 3.5. And it started at 10, so we know that is its y-intercept, where it started. Now our questions just match up with the graphs here. Which of the trees is growing the fastest? So which one has the biggest rate of change? So A, B, or C. It would be B here. It has the biggest number in front of the X. Which tree was the tallest when it was first planted? So that would be your y-intercept. Which one's the tallest? Well, it looks like C was the tallest. It started at 10. And then which tree is the tallest after 6 months? Well, we know in the graph, it's easy to see, it was 31 inches in the graph. Well, to figure out the other ones, you can kind of either guess or plug 6 in for x into either of your equations, because x represents the months. So if you were to plug it into this equation, we have 4.5 times 6 plus 3, which gives you 30, or 4 times 6 is 24, plus 5, $29. So which one is the biggest? It would be still letter C. All right. Very last kind of question is the distance versus time pictures. So if you forgot, we use the words linear, nonlinear, increasing, or decreasing. So from 0 to 4, it's kind of going downhill, so we know it's decreasing, and it's not a straight line, so it would be nonlinear. So nonlinear decreasing is how you would describe that. So for here, from 4 to 10, see if you can figure out if it's linear or nonlinear, and increasing or decreasing. Okay. Last picture is this here. If you're given 3 different lines with distance and time, you should be able to come up with some kind of conclusion about them. So first, which runner maintained a steady pace? Well, which one's the one that's completely straight and never changing? It's B, so he is going at a steady pace throughout his race. Which one gradually increases? Which means which one starts slow and then kind of gets a little faster? That would be letter C. Which runner slows down at the end of the race? So he starts out really, really fast and kind of slows down towards the end. That would be A. And here's my question to you guys. List the 3 runners in the order that they complete the race. So I would look at the time, which ones finish first, second, and third, and put them in order from first to end the race and last to end the race. All right. I do want your input on whether or not we should continue to use Edpuzzle or not, so I would like your feedback on this. But again, if you have any other questions on any of these topics, I am willing to either shoot you a message or put up another video, so please let me know your thoughts.